Hey trick class, let's look at solving an equation that involves a double angle, right, within an interval. So what we have to do here is understand that cosine has more than one representation. It can be cosine squared minus sine squared. It can be 1 minus 2 sine squared. Or it can be 2 cosine squared minus 1. So I have all these different variations. Which one am I going to pick? Well, I'm definitely going to pick this one because the other term on the side with the cosine there is sine squared. So I'm going to transform everything to sines and then solve the equation via the sine function. So this is the cosine of 2 theta. So I can write this new equation as 1 minus 2 sine squared theta plus another 6 sine squared theta equals 4. And you've noticed these are now like terms. So this is 1 plus 4. Sine squared theta equals 4. All right, I'm going to isolate the sine squared. I'm going to subtract 1 from both sides. So now I have 4 sine squared theta equals 3. Dividing both sides by 4 would give me sine squared theta equals 3/4. And finally, taking the square root of both sides, the sine theta equals plus and minus the square root of 3 over 2. So looking on my unit circle, I'm trying to find where is sine, where's the y coordinate equal to the square root of 3 over 2 or negative square root of 3 over 2. So it happens there, there, and there. So the angles that we're looking at are pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. All right, so now I would verify, I would check with my calculator. So make sure you're in radian mode. I am. I'm going to type cosine 2x instead of theta. I'm using x here. All right. Remember, when we square the sine function, we need to do it this way. Sine x, close that, squared. All right, so there's the left-hand side. I hit enter. All right, the other side is y equals 4, so I'm just going to type 4. All right, and then my interval is 0 to 2 pi, so I'm going to do window. My x minimum is 0. My x maximum is 2 pi. All right, I'm going to I always make my scale multiples of pi over 6, so I do second pi over 6. Now the value that we're crossing here is 4, so we need to make sure we at least go up that high. We have cosine, we have a 6 for sine, so we could go up and down 1 from 6. We can go up and down from 0, like we can go up to positive 6, down to negative 6. So negative 6 minus 1 would be negative 7. Positive 6 plus 1 would be positive 7. So I'm going to make this go between negative 7 and positive 7. And I'm also going to have a scale of 1 there, so I can see all the tick marks. All right, let's graph it. All right, there is our left-hand side. There's our y equals 4, the other one. And there are the intersection points. Now we said pi over 3, 2 pi over 3. So let's trace. Let's hit trace and type in pi over 3 and verify that that's an intersection. That's our first intersection. Now that we've done it one time, we don't have to keep pressing trace. We can just type the numbers in. So now 2 pi over 3, there's that intersection. 4 pi over 3, third intersection, and finally 5 pi over 3. And there's our fourth intersection. So the calculator is a great tool for verifying, checking your answer. Left side equals right side. The only thing is that you would have to find these values. You would have to approximate them. It's not going to show you x is 5 pi over 3. It's going to show you that decimal approximation. All right. One little trick you can do, if your intersections are not happening at the peaks, if they're like happening somewhere within the sine cosine wave that you're seeing, you can use the intersect feature. So I can do second calc. Intersect is number 5, and I just need to find one of these. So let's just use this one I'm closest to. So it's saying first curve is at this one. So it is. That's the left-hand side. So I hit enter. Second curve is at y2 equals 4, the right-hand side, and that's right, so I hit enter. And then it wants me to guess where are you wanting to find the intersection. So that's pretty close to where the intersection occurs, so I just hit enter there. And so there's my intersection. And notice it says x equals this, y equals 4. But this is now x. So if I hit second quit on the main screen, if I just hit the x button and hit enter, it gives me that value that it just found. Well, remember that, again, it's an angle. That's what we're trying to find here, theta. Those are angles. So typically, if it's a special angle, it's a multiple of pi. So I can divide by pi. Now we've pulled the pi out of this, and I can do math into a fraction. And so stick the pi back in there, 4 pi over 3. That was the intersection that we found. So I can find all these intersections using that intersect feature. I would just have to scroll until I got on the intersection I'm trying to find. All right, now that number is stored as x. If I hit x, you can see now that number is the value for x. So I can divide by pi, change it to a fraction, and there's 2 pi over 3. There's that intersection. So your calculator can do these. It's just, again, you have to understand if it's a multiple of pi, it's going to give you a decimal approximation. So if we divide the pi out, we can get the number that pi is being multiplied by, and then just manually stick the pi back in there.